Problem 1A. What is the transmission delay from R2 to server A? To find the transmission delay from R2 to server A, divide the size of the packet, which is 12,000 bits, by the transmission rate of R2, which translates to 50 million bits per second. This will give you 0.24 milliseconds. B. Find the maximum number of packets per second that can be transmitted by the link from R2 to server A. To find the max number of packets per second, take the transfer rate, which is again 50 million bits per second, divided by the length of the packets, which is 12,000 bits. That gives you 4,166.67 packets per second. Problem C. Find the end-to-end delay from host A to server A. To do this, you would need to find the delay at each link, be link 1, link 2, and link 3. Link 1 is host A to R1. The transmission delay is 12,000 bits, which is the size of the packet, divided by the transfer rate, which is 30 million bits per second. It equals 0.4 milliseconds. Propagation delay is 1,000 meters, which is the length of the distance between host A to R1, and then divide that by the speed, which is 300 million meters per second, which equals 0.00333 milliseconds. To get the total delay from host A to R1, add the transmission delay and the propagation delay, and that will give you 0.40333 milliseconds. I'm going to do the same thing with the two remaining links, the next one being R1 to R2. Transmission delay is 12,000 bits, the size of the packet, divided by the rate, which is 30 million bits per second, which will give you 0.4 milliseconds. The propagation delay is 20,000 meters, which is the distance between R1 and R2, again divided by the speed, which will give you 0.06666667 milliseconds. To find the total delay from R1 to R2, add the transmission delay, 0.4 milliseconds, plus the propagation delay, which is 0.06666667, which will give you a total delay of 0.46666667 milliseconds. I'm going to do the same thing again with link 3, R2 to server A. First, find the transmission delay, which is 0.24 milliseconds. Then I'm going to find the propagation delay, which is 0.00666666666 milliseconds. Gives us a total delay of 0.24666666666 milliseconds. So to find the total end-to-end delay, you're going to take each of these delays, the three links, add them together. That's going to give you 1.17 milliseconds. It's rounding up. So problem D, find the end-to-end delay from host B to server B. It's very similar to the prior problem. You would need to identify the links. There are 3 again, and then find the transmission and propagation delays at each link. The end-to-end delay is the sum of these delays. So just like the previous problem, the first link, we're going to find the delays. So host B to R1, the transmission delay is 12,000 bits divided by the rate, 20 million bits per second. It's going to give us 0.6 milliseconds. Propagation delay is 2,500 meters divided by 300 million, which is the speed at which it's transferring. It's going to give us 0.008 milliseconds. It's rounding up for the video. Total delay is 0.6 milliseconds plus 0.008, which will give us 0.608 milliseconds. Then we're going to do the same thing with R1 to R2. Transmission delay is 0.4 milliseconds. The propagation delay is 0.0667 milliseconds. Total delay is a sum of these of the transmission and propagation delays, so 0.467 milliseconds. We're going to find the delay at link 3, which is R2 to server B, which is the last link, and the transmission delay is going to be 0.17142 milliseconds. The propagation delay is going to be 3,000 meters divided by the speed, 300 million meters per second, which is going to give us 0.01. The sum of these 2 delays is 0.18 milliseconds. The end-to-end delay from host B to server B is 1.26 milliseconds. As far as whether or not there would be any changes or noticeable changes in the end-to-end delay, there would not be due to the small size of the packet and the transfer rate. All right, problem E. What is the maximum achievable end-to-end throughput in megabytes per second? Assuming the middle link is fair shared. Middle link is R1 to R2. It's fair shared by both hosts, and so since it's fair shared, we're going to divide that middle link rate divided by 2. So it's going to be 15 megabytes per second. And that would be the maximum throughput for each client to server pairs. All right, problem F, find the bottleneck link from host A to server A. I apologize, find the bottleneck links for each session. So the bottleneck link from host A to server A is, there are 2, they're both the same. It's the link from host A to R1 and R1 to R2, since they both have a rate of 30 megabytes per second, compared to the third link, R2 to server A, with a 50 megabyte per second transfer rate. So since 30 is the lowest rate, then that's what the bottleneck link would be considered. So it would not transfer higher than that. The bottleneck link from host B to server B is the link from host B to R1, has a rate of 20 megabytes per second, which is the lowest of all 3 links. So nothing would go faster than the 20 megabytes per second.